Good morning, everyone. So a couple of things before we get started. I did go through most of the homework. If you're towards the end of the alphabet, alphabetically, I think there's 6 of you that I haven't gotten to yet. Feel free to check your grade in Google Classroom. And the comments I've been putting, please go back. A lot of people still didn't resubmit. Maybe you didn't see my post yesterday. That's fine. You have a chance to correct it for full credit this week still. You can go see kind of what you did before I put them into Power School later this afternoon, hopefully around noon. So around lunchtime is my goal to finish them up and get them typed into Power School. But remember, you should preferably turn it in Google Docs. It's easier to read than a slide. And it should be all of the classwork and then the notes and then the homework. Whatever order we do them in, that's what order it should be in. So problem 1-12, I think, was our first assignment last week. So that should be the first thing posted. And then the last thing would be your work from the Kuda Works worksheet. So some of you, I think, maybe didn't show me your work this last week, and I said that was fine. I wasn't going to make you go back and redo the whole assignment. But you have another worksheet this Thursday, I do believe, for homework, and make sure you are showing the work and then submitting those pictures of the work. A few of you have not even signed into Kuda Works yet. Your original email didn't work. I sent you a new email saying make sure you get this up to date. So some of you have zeros. And the way Kuda Works operates is as soon as whatever I set the due date as, if you're not done, it cuts it off for you. So you have to email me asking me to reopen it if you want to submit it late. So keep that in mind. If you haven't made your account, maybe make yourself a note, and you need to do that as soon as we get off today so that you can do this week's assignment. And if you want to go back, you can go back and do last week's assignment as well. So that's where we are with those assignments. I also posted something for you, and I said you don't have to print it. It's just going to be a little bit easier if you do print this. So I posted it in Classroom with the assignment, and then I reposted it again yesterday saying you can save yourself some time if you set this up ahead of time if you don't have a printer. But this, filling this paper out is what we're going to be working on today and tomorrow. So today we'll do, I don't know, 5 or 6 of them. Tomorrow we will finish them, and then we have some additional notes tomorrow. So if you have any homework questions that are coming up throughout the week, bring those tomorrow as well. So this is the paper I'm talking about. If you were able to print it, awesome. Like I said, if you're not able to print it, it's not that hard. You can just set up a table and fill it in as we go. This would just save you a little bit of time. And so this first one, we'll just go ahead and get started on these. So let's see. I'm gonna date it. Okay, so our first one, the family name y equals x squared, we know is a parabola. Or a quadratic. So it's a quadratic, and then the shape of the graph would be a parabola. I would accept either one there for the family name. And like I said, just so you guys know, this is problem 2-25. It's kind of 25 and 51 put together. They wanted you to explore these in groups and make posters, but we don't really have that option right now. So the math teachers decided it was easier as notes. So the general equation, we worked on this yesterday, is y equals a parentheses x minus h squared plus k. There we go. So the locator point for a parabola is the vertex, which we know is the point HK. Parabolas have no asymptotes. This end behavior, this is going to be a little new. Once we graph it, we'll come back and look at the end behavior and the domain and range. So our parabola y equals x squared. We know it's just something like that. We're also going to do an example for each of these. On our example, I'm going to do a is equal to negative 2, h is equal to 3, and k is equal to 4. So our equation here will be y equals negative 2 parentheses x minus 3 squared plus 4. So here we know our vertex is 3, 4. And the negative 2 makes it open, down, and is skinny. So for the domain and range, the domain is everything we plug in for x. So you're allowed to plug in anything you want for x. So the domain is going to be all real numbers. You can write negative infinity to infinity if you want, remember, or it's the capital R with the 2 vertical lines. Our range is a little bit trickier though. So if we look at this original parabola, our range is everything greater than or equal to 0. If we look at the shifted parabola, it's less than or equal to 4. So the range is going to be y is greater than or equal to k. And this is if a is positive. If a is negative, this just switches to a less than symbol. So y is less than or equal to k if a is less than 0. And then the way end behavior works, so it's kind of as the graph goes left and right forever. So as x goes to negative infinity, so as we go to the left forever, and we're just going to focus on if a is positive. As x goes to the left forever, y is going up. So again, negative infinity for x, this means as we go to the left, and then this means as we go to the right. So as we go to the left, y is going up, so it's going to positive infinity. And as we go to the right, y is also going up, so it also goes to positive infinity. So again, negative infinity for x, that means left. And that means as we go to the right. And then this means we go up for both of these. Again, this was just if a is positive. If a is negative, everything's going to flip. It would be negative infinity there. All right. Any questions on that parabola before we move on to the next one? And if something doesn't make sense, like I said, just stop me along the way. So next is the cubic. The equation is y equals x cubed. The general equation is almost the exact same, except instead of squared, it's just the function is cubed. So y equals x minus h cubed plus k. We call this HK the inflection point. So the inflection point you'll see when we graph it, it's where it ends up turning. So our cubic looks something kind of like that. So this point here, HK, and in this example is 0, 0. It's where it turns there. So again, we have no asymptotes. As x goes to negative infinity, so as x goes left, y is going down. So this will be negative infinity. And as x goes to positive infinity, so as x goes right, y is going up. So that's also going to be positive infinity. Or not also, that one is positive infinity. And again, this is if a is greater than 0. When a is negative, we'll do our example, we'll see that it flips. Remember, domain is all the x values. We can plug anything in we want for x, so the domain is all real numbers. And then the range is also all real numbers because this goes down forever and up forever. And again, we'll do this example, y equals -2 times x minus 3 cubed plus 4. I'm going to use these same a, h, and k values on all of them. So our inflection point is hk, it's still 3, 4. And then the -2, it's just like the parabola. It's going to make it skinnier or go up faster, and then the negative flips it upside down. So this one's going to look kind of like this. This next one should be a review also. We haven't done it in a while. I think it was chapter 9 of math 2, but we know this is absolute value. The absolute value graph is very similar to a parabola. So our equation is y equals a absolute value of x minus h and then a plus k. I want to be careful, remind you guys to be careful. A lot of people write the absolute value bars and then still write squared. Don't do that. The function here is absolute value. We don't square anything. So our locator point is HK again, which is the vertex. We also don't have any asymptotes because this one goes like this. So again, as x goes to negative infinity, so as we go up, or sorry, as we go left, we're going up. So y is going to infinity. And as we go right, y is also going up. So it's going to infinity. Again,
no need to apologize.
This is if A is greater than 0. Okay. Our domain, again, is all real numbers. We can plug anything in we want for X. We're not going to get any kind of error. And then our range here is going to be Y is greater than or equal to K. Also if A is positive. We'll do our example with A negative and you'll see how it switches. In this problem, we know the range is greater than 0 because that's our K value was 0. All right, so my vertex here is still 3, 4. -2 makes it go down and it makes it skinnier. So you can see on this, it's kind of hard to tell, but I'm using purple, so it's a slightly different color. On this one, the range is going to be less than or equal to 4. So again, if A is negative, it switches this symbol here. So anytime we're writing if A is positive, know that it's going to flip whatever it is for when A is negative. Questions on this first page before we go to the next page? No? Okay. So this next one is the exponential. Which hopefully looks familiar from Math 1. So typically we're used to seeing the equation y equals b to the x. For this, you have to pick a b value. So we just chose to stick with b equal to 2. So our general equation is y equals a times b to the power of x minus h, and then plus k. So the x minus h is in the exponent here. So on all of these problems, wherever you have the x, we put a minus h with it. So since x was in the exponent, it's minus h in the exponent. The plus k goes at the end, and then you multiply by a in the front for the coefficient. So here the locator point is a little bit tricky. So hk is on the asymptote. So if you plot the point hk, it's not really going to help you because it's on the asymptote. So the point that we end up using is h comma k plus a. And we'll go over that in the example in just a minute. Your asymptote here is always going to be y equals k. So we'll come back to these two. So we know y equals 2 to the x. Looks like that. Where this is the point 0, 1. And then we know this was our asymptote. I don't know, can you guys see that there's a yellow highlighter there? And then for our example, y equals -2 times 2 to the power of x minus 3, and then a plus 4. So since k is 4, that's our asymptote here. So this line is at y equals 4, because that's our k value. So again, HK here is 3, 4. That's on the asymptote. That's what I was saying here. HK is on the asymptote. That doesn't really help us with our graph. We want to plot HK plus A. So since A is -2, we go down 2, because that's our A value. So we have the point 3, 2 that's on our graph. But again, I think this is the trickiest one. HK is 3, 4. And then you add A. Since A is -2, we go down 2, and we get this point. So this graph, this is our asymptote. Looks like that. Okay. So for our end behavior, as x goes to -infinity, so as we go left, you can see here it's getting close to 0, here it's getting close to 4. So y is going to get close to k. So it's not going up or down, it's getting closer to this asymptote. And then as we go to the right, here it goes up, here it goes down. So as we go to the right, or positive infinity, y goes to infinity if a is greater than 0. And again, if a is less than 0, if a is negative, we know it's going down. The domain here is all real numbers. X can be anything we want. We don't get any kind of error from plugging in a number. The range is y is greater than k. Again, that's if a is greater than 0. So when a is positive, y is greater than k. If a is negative, it's less than k. Notice this one doesn't have or equal to. That's really important because it's an asymptote. This is never going to make it to 0. This is never going to make it to 4. So this won't have the or equal to. It's greater than k if a is positive, and again, it's less than k if a is negative. Next, we have the square root function, which we did 1 or 2 of these last week. I think it was problem number 12, but we didn't really, we just kind of plugged it into the Desmos and saw what it looked like. So our equation is the same thing. Y equals a in front, then our function, which is the square root. Wherever x is, you put minus h. And then outside of your square root is the plus k. Here, hk is the endpoint. So square roots have an endpoint. They don't go forever in both directions. And they're not going to have an asymptote. So this equation, y equals the square root of x, looks just kind of like that. So as we go to the left forever, y doesn't exist. There's nothing on this left side of the graph. So y does not exist. We can't go to the left. There's no points over there. And as we go to the right forever, we're going up. Again, this is if a is greater than 0. These all flip upside down when a is negative or less than 0. We'll fill in the domain and range after this example. So y equals -2 times the square root of x minus 3 and then a plus 4. So 3, 4, my HK, that's my endpoint. That's kind of where this graph starts. And then it goes like this. So it's kind of stretched taller. It doesn't curve as much as quickly, and it goes down. So looking back at our domain here, for this original graph, it was all positive numbers. For here, it's everything greater than 3. So our domain is x is greater than or equal to h. And then our range is y is greater than or equal to k if a is positive. So here it's bigger than 0, and here it's less than 4. And you're not necessarily expected to memorize all of these. That's why I printed it, and if you're writing it in your notebook, just kind of maybe put a Post-it or flag the page somehow so that you can always refer back to this. And then if you graph this in Desmos, hopefully you can figure out the domain and range based on your graph.